So you've printed the Hello World board with the V1. Now what? What else can you do with Voltaire's PCB printer that's a little more complex? Using some of the fundamentals we've seen with the Hello World, I'm going to take you through a bit more involved build today that our partners in Korea, ITIZ, developed as part of the curriculum for their students. To save time, we've set up an assembly line of V1s, but you can definitely print these all with one V1 if you like. The cool thing about this project is that once you build the first board, it becomes modular. There are a variety of different functioning boards you can connect for different results. Today, we're going to build 4 boards that connect to each other, each with some pretty cool results. The first board is really the power plant of the rest of the boards, the NE555 spherical wave pulsation circuit. We'll just call it the pulse generator. For the pulse generator, we'll be using an LED, a capacitor, some resistors, and the key component for this board, the NE555 timer IC. An IC that's 50 years old at this point. This board is essentially the same as the Hello World board, but with the key difference being that we can adjust the frequency of the pulse generated by the 555 timer. To do this, we use a potentiometer. It's actually the same thing that's in the volume knob of an electric guitar. The final result of this board is you'll have an LED that blinks to illustrate that the pulse generator is sending out a pulse. The pulse that will affect the next 3 boards. All right. So board 2 is called our LED sequential switch. It's basically an array of LEDs with resistors blinking at different intervals dependent on the pulse from the pulse generator. The cool thing about this board is usually with so many LEDs, you would need 1 pin for each light that you're trying to run. But of course, we've only got 3 inputs on that board. So instead, we use this IC, which manages all those LEDs. And every time it gets a pulse, it switches which pin it outputs to, so we can use them all, even with just 3 pins. Now we get into something a bit more complex as we move into our third board, the 99 decimal counter. While it's a bit more complex, it builds on the principles we talked about in board 2, using ICs to manage LEDs. Each of the 7 segment displays are functionally just 7 LEDs in specific positions that change the display to numbers. So in order not to waste space with a bunch of traces, again, we use ICs to manage these 14 LEDs. 2 ICs are used to manage each of the 7 segment displays, but the 5th IC uses a couple of logic gates to reset the other ICs so that they loop. When you get to 9, you go back to 0. The result is that every time we get a pulse, the counter goes up by 1. Moving on to our 4th and final board, the Roulette. This board looks somewhat similar to board 2, seeing as at a first glance, it's just another array of LEDs. It also looks like a certain ship from a certain franchise from a certain time long, long ago. An interesting part comes when we look at the way this board is designed. Usually, when you design a board, you're working with 4 layers. This is helpful when you get into complex designs that require certain lines to cross. However, the V1 only prints using a single layer or a 2-sided board if you're doing through holes. But there are still creative ways to get around these cross lines. Jumpers. Jumpers are resistors in name only. They're basically empty and provide no resistance. Instead, they act as a bridge over traces, allowing the pulse to cross over lines while working on a single layer. Well, why should I care? Why not just work with something that has multi-layer capabilities? Well, printing 1 layer when prototyping can help you keep your circuit cheaper to produce, so using creative workarounds like jumpers can decrease the cost of your final product and also allow you to iterate faster. That's key. You can always roll your design into a multi-layer board when you go to production for whatever you've built. As I mentioned earlier, this project is modular, so there's actually a few different other boards that ITIZ has designed that we didn't get to. For example, you can build a board that slows down the pulse generator, and another cool one that lights up pips and functions as an electric set of dice using LEDs. So there you have it. A bunch of cool ways to experiment using the V1 for various different designs and projects while exploring its capabilities and how it can work for what you're trying to do. So you can see here, I've got the power and the ground connected, but no pulse. So it shouldn't really be doing anything. But then when I touch this pad, it goes super fast, way faster than it was going before. I'm pretty sure I know why, but let me see if you know why. Hit me in the comments and let me know what you think.